I've heard of object-oriented programming, but how does it apply to developing on the Salesforce platform? Bhavana Singh will uncover the mystery of object-oriented programming, how it applies to Salesforce development, and so much more. Welcome to 100 Days of Trailhead, where the tech community comes to learn Salesforce, learn tech, get inspired, and invest in ourselves. We are your trail guides, here to support you on your learning journey. We release videos weekly. Hit the subscribe button so you don't miss a video. In the description below, you can find links for everything we mention in this video, as well as books and resources we found useful. Visit our blog, 100daysoftrailhead.com, for other helpful Salesforce and tech content. Object-oriented programming is prevalent in many areas of development across tech, including Salesforce development. Today, Bhavana Singh is diving deep to define object-oriented programming and how it applies to Apex development on the Salesforce platform. Bhavana is a Salesforce MVP, Golden Hoodie winner, and a Salesforce registered partner. Her company is called 3 Moons Consulting. Her educational background is electronics engineering and computer science. She's had many fun jobs, from NASA's Command and Control Center to the trading floor of a hedge fund. She is a certified application and system architect. Bhavana leads the Marilyn Witt Group and is a Rad Woman coach.
Hello, everyone. I'm here to talk about main principles of object-oriented programming. So change is inevitable. Anybody who writes software knows that the code that you write today is guaranteed to change tomorrow. So what can you do to make it easy to change? Because we all know that when we have something that's already working, we hesitate to touch it because we're always afraid we might break something else. So is it worth investing the time upfront in a sound design so that the changes later are easy? Hi, my name is Bhavana Singh. I'm a Salesforce MVP. I'm a Rad Woman coach. I'm a consultant, developer, and architect, and I'm a lifelong learner of software development. And I love to teach what I know, and I also love to learn from everyone. So I have a question for you. Where do we spend more time on the code we write? Do we spend more time before or during the development process when we're first writing the code? Or do we spend more time after the development process is complete? So from my experience, I know it for a fact that we spend a lot more time after. Software is rarely ever done after the first implementation. We always spend more time maintaining and changing the software than the time we spent initially writing it. So what can we do to make the change easy? How do we do it well enough upfront? I mean, I have together code in the past that worked, and it was fine until time came to change it. So should I have taken the time to do it well to begin with? I know sometimes we don't have that luxury in the schedule, things come up, there's an emergency, and then you need to just write some code quickly and get something working. But I'm not talking about those times. I'm talking about a project that has the time to follow all the phases of software development lifecycle, and it has time dedicated for design phase. So like someone says, whatever is worth doing well. So I believe we should learn these principles and maybe use them upfront during the design phase. So today I want to talk about the 4 principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. There's no need to reinvent the wheel. We can use what others before us have pondered and perfected. We just need to be aware of these things and make them part of our tool set when we're designing new software. So my goal today is to introduce these concepts in case you haven't heard about them, or help you revisit them if you haven't thought about them in a while. And then my hope is that following this presentation, you will deep dive into them as time permits. So let's start with abstraction. Abstraction is a less detailed representation of something, the idea of something. It makes things easy to understand by hiding the complexity. It defines the generic types of behavior. Think of it in terms of a cell phone. We know that almost all cell phones have some kind of user interface. There is a screen, there's an on-off button, something to control the volume, a way to key in data. We don't really need to know exactly how it works behind the scene when we look at a big picture. So, but we have an idea of how it works because it has those things. Everything else is abstracted out. So abstraction in Apex is supported using interfaces and abstract classes. So we hide the complexity at the abstract class level or interface level and allow the subclasses to detail out the implementation. And we will see examples of this later on. The next concept is inheritance. Whenever you hear of is a relationship, inheritance might be useful there. For example, red wine is a type of wine. White wine is also a type of wine. If we are defining them as classes, we might want to put out all the common attributes and behavior into the parent wine class. So inheritance allows you to use code of existing superclasses. So suppose you have a superclass called shape, and then you have two subclasses called circle and rectangle. Now, if you want to add another subclass called triangle, it can benefit from the existing code in the superclass, and it only has to implement things that have triangle specific behavior. So primary benefit of inheritance is not to repeat the code, it's code reusability and readability. When everything is the same, but a few features are slightly different, we use inheritance. Some people avoid inheritance because it makes the parent and child classes tightly coupled. You cannot use one without the other, but inheritance has its place, and so we need to be aware of this principle. The next principle I want to talk about is polymorphism. It comes from ancient Greek, where poly means many, so polymorphic means something that can take many forms. So polymorphism is closely related to inheritance. We can write code that calls the superclass, but later on we can replace it with any of the subclasses and it will work. For example, if we have a method called draw in the superclass and we call it any of the subclasses of their superclass, we'll make that method call work. They will either use the one from superclass or provide one of their own. But in either case, the method signature and what it returns will exactly be the same. So this is a really powerful concept. There are many uses of it. For example, we are looping through a list of S objects and doing something with them. We don't care about the specific records or objects. So we are looping through, say we are looping through and sending email and attaching it to each, or we have an array of, I don't know, like multiple S objects and we are printing something to the debug log. So polymorphism allows us to treat them all the same because we just call the methods on whatever's on the parent class, and it would work on all the subclasses. And we can also add new classes in the future without worrying about breaking this particular loop where we are looping through the S objects. And again, we'll see more examples of this in a little bit. And finally, I want to talk about encapsulation. It can mean many things. It primarily means bundling related data and behavior together in one class. So hide what they don't need to know, only show them what they need to know. It helps protect your data. You don't want the outside world to change it. You want to control that. The attributes and behavior should be encapsulated and protected from changes from outside influence. And you want to protect your business rules. You want to be able to change them without breaking the rest of the system. This concept is really important, not breaking the rest of the system. Like I was saying earlier, so many times we hesitate in making a change because we don't know what else it will break and how long it will take to fix it. I think we've all been there. There's like complex code base and we have no idea what it will break if we change just one thing. But if we have classes nicely encapsulated, and you're keeping the signatures of all the public methods the same, in other words, not breaking the contract with other classes, and you have unit tests that provide 100% or as close to it coverage for the class, you can be confident that changes won't break anything in the rest of the system. Remember how I said the change is inevitable? Well, without encapsulation, that change is very messy too. You could have if you have classes modifying values in many places and into other classes, and when business rule changes, you have to touch all of those places. The more places you touch, the more you have to test and the greater of chance of missing something and breaking something. However, if all other classes only have access via getters and setters, then you just need to change in one place. And as long as you have good test coverage for the class, you can be confident that things will not break. So in Apex, we use encapsulation to hide the state of data inside a class. They then publicly accessible methods, getters and setters, are used to access the data, and I'll shortly show you some examples. So these are the keywords we use to accomplish the things we talked about. Interfaces, abstract, virtual keywords allow us to have abstraction. Extends and implements keywords on a class allow us to use the concept of inheritance and polymorphism. The attributes, and methods public, private, protected, allow us to provide encapsulation, and also virtual and override or methods also allow us to use inheritance and polymorphism. I copied this from Salesforce developer documentation to show all the keywords in the same place for a class. I'm sure you have seen this before, and hopefully now these make some sense or more sense. Similarly, I also copied this from the developer documentation. This is the syntax for variables, all possible things, and also for methods. All right, let's look at some code now. So I created this made-up scenario. I want a database of all my wines, and I want an application where I want to look up things and about wines based on its name. I want to enter the price I bought this at, and then I want the ability to see how much it costs now. So we can start by creating a class called wine with some attributes. I am going to switch over to VS Code. Wait, whoops. Okay. Okay, I'm back. So let's look at some code. So, so this is the wine class I was talking about. So I have a wine class. It has 3 attributes: public attributes, name, year, and the price. And there's a constructor, and there are 2 public methods. So let's look at how someone might be using this class. So sorry, my Zoom keeps getting in the way. Let me move this out of the way. Okay. So okay, so we have this class that's using the wine class. So I create a new instance of the wine class, and I give it a name and the year and the price, and just pretend this happens, some other time. And then this is the consumer of the application that I was talking about. And so I look up the price. I could use the get price method, but you know what? I have access to price. So I'll just directly, this is public. So I will just directly access the price. And then I was like, you know what? If the price is greater than 10, I want to change it. Wait, what? You shouldn't be allowed to do that. But then whoever wrote the wine class has everything open. So so this is a problem. This is not good. You shouldn't have other people or application using the data setting up the price. So how can we fix that? So one thing we can do is, if I make this private, and if I save it, then if I go here and then I try to save it, it should complain if I try to do, oh wait. Okay, if I save it, I usually deploy this to org, make my change, and then because I made that thing private. And then if I come back here, and now let's see if I can also save this to my org. And it should complain. And it is complaining. It's saying variable is not visible. So it's saying these 2 places you're directly accessing now that I made this private is not visible. So this is encapsulation. We are hiding the actual price data, and we are giving it access via getter and setter. So in order to fix this error, I would say get price. And I am no longer able to do that. Nice try. You can't do that. Okay, so now our price is nicely encapsulated, and we can do similarly for the other things. We can have getters, and if we do want the application to set the price, we can provide a setter. So we could say set price and take a double, a decimal, and price, and then we can set our price. So this is, we are allowing this to happen. So we are controlling what happens to this data. We are not just like, nobody can willy-nilly just go and actually change it. And if we know we allow, then we know that we have allowed others to set the price, not that somebody just did it because our data was not properly encapsulated. So that's the basics. So let's evolve this some more. So let's create some more things in this wine class. Okay, so we have this wine class, and it has lots of attributes. Color, sweetness, is it sparkling, and it has a constructor, and these methods. There's a public method. There's some virtual methods. There's some abstract methods. So why do we have all that? We have a requirement that some of the wines are red and some of the wines are white, and then we have wine-specific things that we wanted to do. So we could do this, right? We could do, okay, so what kind of wine glass do we know? So we can say if it's sparkling, then this should be flute. If it's red, then do this. If it's color, if it's white, then do this. So anytime you do if then like that based on a class, maybe it is beneficial to explore if each of these conditions should be a separate class, So instead of having this if then else on the type, we can have a subclass define it. Obviously, this example here is simple, but imagine if this was something that required lots of calculations and lookup. This code would be long, and this class would go very long, and this would be because every time we had to do something wine specific, we say, oh, if red wine, do this, if white wine, do that. So that would be harder to read. And then every time you want to add a new wine, nowadays they have orange wine. So if you want to do, you have to go all the places and change, okay, if orange wine, then do that. So that's messy, and then the change is hard, and you're touching everything and could cause things to break. So what we can do is we can make this class an abstract class. So that's something that other classes can extend. So this would be an example of inheritance. So we turn our wine class into an abstract class. It has some features that are common to all the classes that would be extending it. So all the attributes, the constructor, get price is doing something different. So we'll get into that in a little bit. But it also has some wine specific things that it would rather have the subclasses defined because it doesn't know at this level. So let's see. So we have some that are abstract that the subclasses must define, and we have some that are virtual. So the subclasses have option either using this or they can define their own. So let's look at one of the subclasses. So we have something called a red wine. So this is a subclass of wine. So we use the keyword extends. So we take the functionality of the wine superclass and we extend it. So when we instantiate it, we pass it. We pass the superclass, whatever is passed to us. And then there were some abstract methods. So we override them with the keyword override. And we say, okay, what grapes were used for this one? It was Syrah, Merlot, and Cabernet Sauvignon. And what was the fermentation medium? It was the French oak barrels. And then we, instead of using the description from our superclass, we decided to just return something here. So that's one class. Similarly, we also have white wine class, which is also gets most of the benefits of using the wine class, and then it does its white wine specific thing, like grapes used in the fermentation medium is steel tanks. And then later on the project, if we say we need to add one more wine, sparkling wine or orange wine, we can just extend the wine class. So inheritance here is allowing us to make these changes fast as compared to not using inheritance, where we would have to write the whole class, everything in a new class. We would, I have seen that. We would be basically copying, pasting the class, and then making the changes for whatever's different for wine class. So, okay, so let's go back to our wine class and look at the get price method and see what's happening there. So remember, initially we set the price, and then when somebody wants to get the price, we just return that price that we set. In this wine class, we have decided to use a wine service to figure out what the price is, because these things change. So we're calling a class called wine price fetcher impl. What is that? Well, wine price fetcher impl is a class that implements an interface called wine price fetcher. So let's look at that for a second. So we have an interface, wine price fetcher, and in a minute you will see why we decided to make this an interface. So when you implement an interface, you must implement all the methods that are defined in the interface. This is an example of abstraction, right? So we know when we call something that implements this interface, they will have a method called getPrice. It will take a string, wine name. So let's see. So let's look at the implementation. I know a long time ago, it used to be a convention to add impl. This is from my Java background, but you can call it whatever you want, whatever that from a glance helps you decide that this is the implementation of some interface. So this implementation is actually calling a wine service and getting the price from the wine service based on the wine name. Since we made this an interface, we can actually create another implementation of it called the wine price fetcher mock, which also implements the same interface. And the reason this is helpful is that when we are writing a test and we're not really actually testing the service, we can just return the data and then go on with the rest of our tests, and we don't have to worry about actually testing it with the outside service. So this is also an example of polymorphism, because we are swapping the wine fetcher with the mock one. So this is polymorphism. I want to show you another example of polymorphism. If I can go back to my demo class. Okay, here. So this is the application that's actually using the three wines we have. So again, pretend that these three lines just happen somewhere where we are actually creating the data and entering it in our database. So we have wine and red wine. I have it mixed match just to show you it doesn't matter, because I said this variable is wine, but I'm saying red wine. It will work because of polymorphism, right? These two are the same thing and can be swapped for each other. So we declared three different wine, and then I have a list on line 14 of type wine, and I can add all these strings who might be of different type as long as they are the subclasses of wine, so they can be swapped. And then on line 19, we are looping through the list, and we can call the methods on the superclass, and we will get the data back either from the superclass or from the subclass if they are implemented there. So again, this is also an example of polymorphism. Finally, I wanted to talk about another example that most of you might have implemented at one point or another. Where did it go? Wine Queueable. So Wine Queueable implements Queueable. So I want to talk about a Queueable interface. if you think about the rest of the system that calls this class, so that would be Salesforce platform, they don't have to worry about the actual implementation of this class. They can be guaranteed that when a class implements Queueable, they will have a method called execute that the system can call. So this is really powerful. Imagine two teams of developers, one that's developing this line Queueable interface. They don't have to worry about how it will be queued. As long as they implement this interface, the other side is the platform developer who's actually writing the code that queues this class. So they don't have to worry about my particular implementation. They can code to the interface. Also, they can change how they do things on their side, and nothing would break on my side. And we can also make change of what I do inside the execute method. As long as I follow, the contract, nothing will break on the other side. So this is the power of abstraction. So yeah, so I have covered a lot. Oops, didn't want to show you my email. So I have covered a lot of concept in this short time. And I just wanted to talk about the next steps. Oh, I didn't want to do that, sorry. I wanted to present. So what should be the next steps? I am hoping that I have, made you curious about this, that you would deep dive into these topics. And if you want to start somewhere, maybe you can start with encapsulation. Maybe you can look at your existing code and see, do you have a lot of public methods or a lot of public, variables that maybe they shouldn't be public. Maybe you should have one public method, which is calling a lot of other internal private methods, and you don't want it to expose it to the outside world. They should only know what they need to know. If they're getting one thing, and then that one method is calling 5 other methods, they don't need to have access to them, then make them private. So maybe you can evaluate some code that you're working with and see how you can better encapsulate it. You can look into interfaces, like I just showed the example. Interfaces can be very powerful. And then when you're coding to interfaces, it makes testing very easy. And I hope you learn and understand abstraction. I have just given you a very quick run through of these concepts, but look into this. There are books out there, look into various resources. And then I'm hoping you'll engage via social media. Maybe you can comment here down below. I think this would be on YouTube, or engage with me on Twitter. And I hope to, learn from you as well. So that's all I have for you today. I thank you for letting me share my thoughts, and I hope to hear from you. Bye.
And with that, we're at the end. Did you have an aha moment when listening to Bhavana today? Comment below. We would also love to hear what video topics you want us to cover in future videos in the comments. If you've made it to this point, we want to take an opportunity to say thank you. Since you've stayed with us, here's a bonus. If you hesitate in touching complex code bases, maybe it's time to go back to the basics and get rid of all the technical debt, and then apply time-proven object-oriented programming principles. Thank you for spending time with us. Please like and subscribe to our channel because we share weekly content to support your tech and Salesforce learning journey. Don't forget to hit the notification bell so you don't miss a new video. We also handpick these videos which we recommend you watch next. Connect with us on Instagram, Twitter, Facebook, and on 100daysoftrailhead.com, all of which are listed below. Thank you for learning with us, and we'll see you back tomorrow.